Welcome to this short introduction to the software Waters Supermica. First of all, you need to install the software. I will provide all the steps in a PDF guide, and the guide will be available in a link provided in the video description. This is the PDF guide. It's about 20 pages and it's comprehensive, covering everything. To use Supermica, you need to do the following 6 steps. You need to create components or automata, and you need to add events in general, and you need to add states. States are added to each automaton, and then you define whether the state is accepting or marked, and then you will add edges, and then you will assign events to the edges. To clarify things, I will work to reproduce the results of this example from the textbook Introduction to Discrete Event Systems. It is example 2.16. In this example, we will define automaton A and automaton B, and then we will make a parallel composition and produce this automaton. So let us start working. So first of all, we need to create the automata. So this is a new automaton. Please select the plant as a default. This is automaton A, and we can create another automaton. It is automaton B. So this was the first step. The first step was to create the components or the automata. Now we will add the events. The events are either A or A and G, or either A or A and G or B, and they are the same events in both automata. So we will add 3 events now, A and B and G. So it's so simple. I will click this one. I will click add, I will name it as A. Let us say that they are all controllable events, and B and G. So referring back, we have finished step number 2. Now we will add the states. For automaton A, we are having 3 states, X and Y and Z. So let us go to the component A. For component A now, I will add, this is X state, and this is the initial state. That's why you could see this arrow. And for Y, this is Y, and for Z, this is Z. So we have added X and Y and Z. I will click this arrow button to be able to select and move the states, X and Y and Z. Okay, by the way, X is a marked state and Z is a marked state. So we need to define this. So I will right click on X and I will mark it as accepting, and I will right click on Z and mark it as accepting. So we have finished for automaton A, adding states and defining whether they are accepting or marked. Now we will add edges. For the edges, we had an edge from Y to X, and from another edge from X to Z, and another edge from Z to Y, plus 3 self loops. So I will add these edges right now. We are having an edge from Y to X. Click again, or click, this already clicked, another edge from X to Z, and another edge from Z to Y. So these are the edges. Now we can add also the self loops. Right click on each state and you can add a self loop for Y. Right click on Z and add a self loop. Right click on X and add a self loop. You can move the self loops, as you could see, to try to clarify. Now we need, after finishing the 5th step, to do the 6th step, which is assigning events to edges. We have event A assigned to the edge from Y to X. So event A assigned to the I'm just dragging and dropping to the edge from y and x. Again, we are having an event G assigned to the edge from x to z. So I will add or assign the event G to the edge from x to z. Again, we are having both events A and G on the edge from z to y. Both events A and G. Okay, so what about event B? Event B occurs on the self loops on Z and Y. Self loop on Z and Y. The self loop on X was assigned an A. So we have finished everything for automaton A. Automaton B, okay, for automaton B, we have two states, 0 and 1. So I will add them, state 0 and state 1. You will not be able to rename them as numbers because the software will refuse. So you will have to add them with a letter and a number as it is there. We are having two edges, one from 0 to 1 and another one from 1 to B. So this is the first edge from 0 to 1, and this is the second edge from 1 to 0. And he is almost readjusting the layout automatically to try to clarify. From 0 to 1 we are having event A. From 0 to 1 we are having event A, and from 1 to B, or from 1 to 0 we are having event B. So I will update to reflect. From 0 to 1 we are having the event A, and from 1 to 0 we are having the event B. Also, we are having two self loops on one end. So a self loop here and another self loop here. And by the way, if you refer back, you will may notice that the state 1 here is a marked state. So let us define state 1 by right clicking on S1 and mark it as an accepting. So the self loop on 1 had an event A, and the self loop on 0 had the event B. So now we have finished almost everything. It is time to test or to analyze. For the analysis, as mentioned, we will make a parallel composition of A and B and get this automaton. So this is what I'm going to do right now. I will click on A and click on B, holding down the control key on the keyboard. And then I will right click and I will click on synchronize. Synchronize means create a new automata, which is the parallel composition of A and B. Okay, he has created the automaton. Now I will double click. This is the parallel automaton. Okay, it should look like this one. Okay, and I will compare them thoroughly in the next figure. First of all, you are having here x and 0 corresponding to x and s0, and we are having this horizontal arrow means that this is an initial state. And then you are having an event G from x and s0 going to z and s0, which is the same. Z and S0 is having here a self loop B. Okay, I believe there is strong similarity. Please watch for Z and S1. Here Z and 1, here is a marked state. That's why you're having this green circle. And watch also for X and S1. It is green here because this is a marked state. Total here you are having 1, 2, 3, 4, 5, 6 states. Also 1, 2, 3, 4, 5, 6 states. I believe it is the same but with some different form. That's all for this video. Thank you very much.